Yeah, who can tell me the formula to find the volume of a hollow cylinder? That is the cylinder mentioned in question numbers 2, 3, and 4. The metallic tube or the iron pipe.
Pi into r square minus small r square h.
Correct. Pi into capital R square minus small r square into h. Correct. And what about the surface area? How do we find the surface area of a metallic tube or a pipe mentioned in question number 2 and 3? Formula to find the surface area.
2 pi r h plus pi r square.
Yeah, correct. Then 2 pi r h plus 2 pi r h. Yes. Okay. So you can see the picture of a pipe. So let's see the surfaces here. So you can see this one. This one is the pipe spoken about in the questions 2 and 3. So inside, we have the inner curved surface area. Inside the pipe, the surface which you see inside the pipe is the inner curved surface area, which is given by the formula 2 pi small r h. Then outside, on the outside of the pipe, on the outside here of the pipe is the outer curved surface area, which is given by the formula 2 pi capital R h. Now, there's a surface here, this one, which is called a ring. This one is called a ring. And to find the area of this ring, the formula is pi r square minus r square, not h. Pi r square minus r square, that's all. If you put h, it will become the volume of a hollow cylinder. Pi h into capital R square minus small r square is the formula to find the volume. Area of this ring is pi r square minus r square. Now, similar to this ring, there's another ring behind also here, which you cannot see. At the other end of the tube or the pipe, at the other end of the tube or the pipe, there's a ring which is not visible. That area is also pi r square minus r square. So the surfaces, we see in this pipe are one, the inner CSA, given by the formula 2 pi small r h inside the pipe. The surface inside the pipe. The surface outside the pipe here, this surface outside the pipe, all this is the outer CSA given by the formula 2 pi capital R h, outer curved surface area. If you add these two, you will get the total curved surface area. If you find 2 pi R h and 2 pi R h and find the sum of these two answers, you will get the total curved surface area. If you want to find the total surface area, not only the total curved surface area, you want to find the total surface area, then you should add the areas of the two rings, one ring here and one ring behind. The area of one ring is pi r square minus r square. So two rings will be 2 into pi r square minus r square. So the formula to find the volume is pi h into capital R square minus small r square. And to find the area, you can find all this separately. You can find this separately, 2 pi RH, 2 pi RH separately, then find the area of one ring, pi r square minus r square, multiply that by 2. and then add all these answers. This answer plus this answer plus this one will give you the total surface area of this pipe or tube. Okay, share your answers. What's the answer for the first one? All right, now let's not waste time. Please check your answer. I'll just take you through the answers. So for the first one, to find the area of the road, see the road, you know, if it's a rectangle, you need the length and the breadth of the rectangle. If it's a rectangle, then you need the length and the breadth of the rectangle to find the area of the road. But here nothing is given about the road. A cylindrical roller, the road roller takes 750 revolutions to level the road. Okay, it moves once. Once meaning 750 revolutions. It has to make 750 revolutions to level the road once. That means the area of the road is the area covered in 750 revolutions. The area of the road is the area covered in 750 revolutions. And what is the area covered in 750 revolutions? In one revolution, the area covered is the CSA of the roller. In one revolution, the area covered is the CSA of the roller. Why CSA? Because when a cylindrical, when something which is cylindrical moves on a surface, only the curved surface area will come in contact with the ground here or the road. Only the curved surface area will roll over the road. So the curved surface area, whatever is the CSA, the curved surface area of the cylinder, this is the area covered in one revolution. So find the CSA of the roller and you'll get the area covered in one revolution. Multiply that with 750. So that is the area covered in 750 revolutions. CSA of the roller is this is the area covered in one revolution. Area covered in one revolution. This is the area covered in one revolution. So if you multiply that with 750, you will get the area covered in 750 revolutions. And this is what it is, which is nothing but the area of the road. If you find the area covered in 750 revolutions, that's nothing but the area of the road. Now this answer is too huge for centimeter square, so you can convert that to meter square. So to convert centimeter to meter, we divide by 100. To convert centimeter square to meter square, you need to divide by 100 two times. So 100 into 100. See, divide by 100 two times, 100, 100. Then centimeter square is converted to meter square. So we have two zeros in the numerator and denominator, they get cancelled. And these two zeros shift the decimal point from here, 1, 2, here. So the answer is 2681.25. 2681.25. Yeah, please take a picture, children. So simple, the answer is to find the area of the road, you must find the CSA of the road roller. That is the area covered in one revolution. Multiply by 750. So you will get the area covered in 750 revolutions. And the area covered in 750 revolutions is equal to the area of the road. Yeah, take a picture, all of you. Or maybe I'll send it on WhatsApp. Very important question. Okay, over to the next one. I'll just leave you with a minute. I'm right here. Just go through the answer and then I'll explain. Have a look at the slide. Yeah, go through the answer and I'll explain. I'm right here, children. All right. So thickness is 1 centimeter, which means W is 1 centimeter. Thickness 1 centimeter, meaning W is 1 centimeter. Inner diameter. So diameter by 2 is radius. So inner diameter is 12. So the inner radius, that is small r, is 6. The small r is 6. So using the thickness and the small r, the value of small r, you can find the value of capital R. Capital R is equal to small r plus W. So capital R is equal to 6 plus 1, 7. And you can see here, find the weight of 1 meter long tube. 1 meter long tube meaning 1 meter is 100 centimeters. 1 meter is 100 centimeters and 1 meter long tube meaning the height of the tube. The length of the tube, which is the height of the cylinder, is 100 centimeters. See, what is given is the inner diameter, right? The inner diameter. This one is given, the inner diameter. This one is 12. The inner diameter is 12. So the inner radius, this one is 6. So that's the value of small r, 6. Then the thickness is 1 centimeter. From here to here, this thickness is 1 centimeter. W is 1. So what is capital R? 6 plus 1, not 61. 6 plus 1, So the value of capital R, the external radius. The external radius is 6 plus 1, 7. And the length of the pipe or the tube is nothing but the height of the cylinder. Is nothing but the height of the cylinder. So we have all the values like this. Yeah. So thickness is W 1 centimeter, inner diameter. So inner radius, small r, 12 by 2, 6. So you have W and small r. So capital R is small r plus the thickness. 6 plus 1, 7. 1 meter long. So the height of the cylinder or the length of the tube, 1 meter, 100 centimeters, because all the other values are in centimeters. Now we need look at this here. 1 centimeter cube of this metal weighs 7.8 grams. It's given here. 7.8 grams per centimeter cube. That means 1 centimeter cube of this metal, whatever metal the tube is made of, 1 centimeter cube, this volume of the metal has a mass of 7.8 grams. 7.8 grams per centimeter cube. So 1 centimeter cube of that metal has a mass of 7.8 grams. So since it is centimeter cube here, it's very clear that you have to find the volume of this tube. So volume formula, pi r square minus r square into h, substitute the values, and here is the answer. So now 1 centimeter cube has a mass of 7.8 grams. But actually in this tube, so much centimeter cube is there. If it is 1 centimeter cube, then the mass is 7.8 grams. But the real volume of this tube is 28,600 by 7. So 28,600 by 7 centimeter cube will have a mass of how many grams? We should multiply this one into this one. That's what is here. 1 centimeter cube, 7.8 grams. So many centimeter cube will be whatever is that into 7.8. So now shift the decimal point. 7.8. No, so make it 78 by 10. We are not converting. 7.8. No, we're shifting the decimal point. So 78 by 10. And then cancel. So you get so many grams. I've divided, meaning I divided by 7. And I got this one. Now, since it's more than 1,000, convert it to kilograms. Because this value is more than 1,000, convert it to kilograms. So to convert grams to kilograms, you should divide by 1,000. 1, 2, 3. Shift the decimal point. 1, 2, 3. Shift it. 31.868 kilograms. So this question is about a cylinder, a hollow cylinder, where the wall of the cylinder is thick. It's about a cylinder, a hollow cylinder, whose wall is thick. So we'll have two values for radius. Inner radius, outer radius, small r, capital R. So we have small r, capital R, and W. Given any two, you can find the third one. See, supposing you're given the small r and W, you can find capital R. Supposing you're given capital R and W, you can find small r. So here we are given W and small r. So we found capital R. H is also given to you in the question. And how do we know that we should find volume? Because it's given per centimeter cube. So we'll have to find the volume. So find the volume and then multiply by 7.8 to get the density or the weight of this 2. Now here in the third one, the question is to find the whole surface area. It's given find the whole surface area. So find, okay, let's see the values first. Yeah. Exterior diameter 25. Exterior diameter is 25. So exterior radius will be 25 by 2. Exterior radius will be 25 by 2. Exterior diameter, so external radius, capital R, 25 by 2. 20 centimeters long. So that means H is 20. 20 centimeters long means H is 20. Thickness 1 centimeter, W 1 centimeter. Now we know capital R and W. So we can find small r. So small r is equal to capital R minus W. See, if the radius from here to here is 10, if this whole thing is 10, and this thickness is 2, if this thickness is 2, then the internal radius will be 8. 10 minus 2, 8. So internal radius is equal to external radius minus the thickness. So 25 by 2 minus 1. So on taking the LCM, you get 23 by 2. So now we found all the values. Small r, capital R, H. So let's move on to find the different surface areas. So the inner surface area, inner curved surface area. This is the formula, substitute the values. And since everywhere we'll have pi, see in this formula we have 2 pi RH where we have pi here. Here also we have pi, here also we have pi. So what I've done is I've not substituted 22 by 7 everywhere. I found all the answers in pi. 2 pi, this is internal radius and H. So 2 gets cancelled and this is the inner CSA. Then outer CSA, 2 and 2 gets cancelled, so 500 pi. Then the area of the 2 rings, because there's 1 ring in the front and 1 behind, no? In the image we saw. So 2 rings, so 2 into pi r square minus r square. So on simplifying, you get 48 pi centimeters square. Now the total surface area of this pipe will be 460 pi plus 500 pi plus 48 pi. So that comes to 1008 pi. Now use the value of pi 22 by 7. And the surface area is 3168 centimeters square. Next one. So this cylindrical drum is open at the top. And there's nothing mentioned about the thickness. So it's just a cylinder with, where the wall is thin or nothing is given about the external radius. So just ignore it. That's all. It's an open cylindrical drum. So where all will the metal sheet be used to make the CSA and the bottom? So the area of metal sheet required to make the drum, the area of the sheet required to make the drum will be wherever the cylinder is, wherever in the cylinder the material is used, only that area you should find. So now this the metal sheet is used to make the CSA of the drum. So find the CSA. And the metal sheet is used to make the bottom of the drum. So find the area of the bottom. The metal sheet is not used to make the lid for the drum because it's an open cylindrical drum. So for the lid, no material is used. The metal sheet is not used to make the lid. So don't find that area. Should find only where the material is used. On top, no material because it's open. So the area of the metal sheet required to make the drum is a CSA plus the area of the bottom. CSA is 2 pi RH for a cylinder and bottom is a circle. Area is pi r square. See, you can also find 2 pi RH separately and pi r square separately and add both the answers. Not that you should do it in one line like this. You can find CSA separately, CSA, then area of the base separately, and then add the two answers also. So here also I've not substituted for pi. Once for all, I use the value of pi 22/7, and this is the answer 16,434 meters square. Per meter square, 200 rupees. 1 meter square, 200 rupees. 2 meter square, 400 rupees. 3 meter square, 600 rupees. So for 16,434 meters square, how much will it be? So it will be 16,434 into 200. Per meter square, it is 200 rupees. So for so many meters square, it will be into 200. All right. Let's continue with statistics. I'll just get a material, children, where I have the questions. Just a minute. Yeah. Children, I just want to check. Mean, median, and mode is a part of the syllabus, right? Because some parts are deleted. I just want to check on that. Have you all learned mean, how to find mean, median, and mode? Yeah, please respond.
No, ma'am. No, ma'am.
No, is it? Oh,
And actually, mean, median, mode was part of Exceed last year, ma'am.
mean, median, mode?
Was part in Exceed book in 7th and 8th, ma'am.
Yeah. Correct. Yeah. But I'm asking, like, now some portions are deleted, right? So do we have mean, median, and mode or no?
No, miss.
No, ma'am.
No. Okay. What about histograms and frequency polygons?
Yes, ma'am. We have.
Yes, miss. Yeah, miss.
Okay, then let me do histogram. Okay, fine. Let me just. Yeah. So how do we construct a histogram? So what is a histogram? Histogram is general. Histogram is the graphical representation of a frequency distribution. But the class intervals must be continuous. Histogram is a graphical representation of a frequency distribution with continuous class intervals. Okay, so on the graph paper, and then here, what can be the scale on the y-axis, children? The minimum value is 6 and the maximum value is 27. So we'll take 1 centimeter, 10 units or 5 units. Okay, let me take 5 units. So because if we take 10 units, then the rectangles in the histogram will be very, very short. the rectangles in the histogram should not be very short also. So let's take 5. So that is 1 centimeter is 5 units. So we'll mark 5, 10, 15, 20. Okay, I want to place here. Let me take the next slide. This is that 1 centimeter. Okay, so 5, next centimeter 10, next centimeter 15, next centimeter 20, next centimeter 25, next centimeter 30. So between this, you'll have like 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this, you'll have graduations. Now let's understand how to read each graduation. Okay, let's understand that first. Now let me just magnify. This is 5. The next one is 10. Now between these two, there'll be 9 divisions here after this. This is 0. Shit. Zero, 3, 4, 6. Yeah. So we mark 5 here. See, I've magnified. This is only that 1 centimeter on your graph paper. There's only 1 centimeter on your graph paper. That 1 centimeter on your graph paper, I've magnified like this. So now how do you read each subdivision? Then 2, 3, 4, 5. This is that next centimeter. This is that next 1 centimeter. That small box like this you have in your graph paper. This one 1 centimeter. That one I've magnified like this. I'm just making it look bigger so that I can tell you how to read the subdivisions. So this is, so now our scale on the y-axis is 1 centimeter is equal to 5 units. 1 centimeter. It's a centimeter graph which we're using. So 1 centimeter is 5 units. Now always divide by 10. Always divide by 10. So what is 5 by 10? 0.5. So let's read the subdivisions. This is 0. Then 0.5, 1. That is, you're using the multiplication tables of 0.5. You're skip counting in 0.5. So 0. Then next is 0.5, 1. 1.5, 2. 2.5, 3. 3.5, 4. 4.5, 5. 5.5, 6. 6.5, 7. 7.5, 8. 8.5, 9. 9.5, 10. So we skip count in 0.5. Whatever scale you have chosen, like we mark 0, 5, 10, 15, 20, 25, and so on. At every centimeter, we mark, we start with 0 and then we go on with 5, 10, 15, 20, and so on. Now we are trying to understand how to read the subdivisions. From between 0 and 5, there'll be some subdivisions, right? The 9 subdivisions. How do you read them? That's what we're trying to understand. Always divide the scale value by 10. Always by 10. 5 by 10, 0.5. Now you jump in 0.5. Skip count in 0.5. 0. 0. So this is 0. 0.5. 1. 1.5. 2. 2.5. 3. 3.5. 4. 4.5. And so on. Now supposing you have taken the scale as 1 centimeter, 20 units. Say 20 units. Okay. You have taken 1 centimeter as 20 units. So every centimeter you will mark 20. Then this is the 5 centimeter mark, children. Yeah. So there's that. So here you'll mark 20, then you'll mark 40 here. This is that 1 centimeter I told you. These are the subdivisions between that 1 centimeter. So your scale is 1 centimeter, 20 units. So you have marked 20, 40, 60, and so on. So now how to read the subdivisions? Always divide by 10. So it's 2. So now skip count in 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. So this is 0. The next one is 2, 4, 6, 8, 10. The middle one is 10, 12, 14, 16, 18, and this is 20. So your graph, no, your graph is like this, that graph paper. These are those. You have marked 0 here and 20 here, children. I'm talking about these subdivision. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm talking about this one only. This one I've magnified like this. So we are learning how to read these subdivisions. 0 to 20. Between that, we have these subdivisions. No, how to read this. That's what we're learning. Then after 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Now supposing we take 30, 1 centimeter is 30 units. You should take a suitable scale. You cannot take anything every time. It should suit the values. It should suit, your scale should suit the frequencies given in the frequency distribution. When you make a histogram, the rectangles in the histogram should not be very short. At the same time, they should not be very tall. So that you should be able to bring that balance. Not too short, not too tall. So you should make that balance by taking a suitable scale. So supposing you take 1 centimeter is 30 units. Then you will mark 30, 60, 90. So you will mark 30 here. Okay, you would have marked 30 here. 0 and then this is 30. Then how do you read the subdivisions? So 30 means 30 by 10. So 3. Each subdivision is 3. So 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. 33, 36, 39, 42, 45, 48, after 48, 51, 54, 57, 60. Keep adding 3. Each subdivision will carry 3. So reading the subdivisions is very, very important. So if you take 4, if you take 4, what if 1 centimeter is 4 units, supposing you take 4 units. 1 centimeter is 4 units. That means here you will mark 4, next you will mark 8. This one is 4. Now how do we read? So 4 by 10, always divide by 10. 4 by 10, 0.4. So 0.4 tables. This is 0, 0.4, 0.4, 0.8, 1.2, 1.6, 2.0, 2.4, 2.8, 3.2, 3.6, and 4.0. So this is 0.4, 0.8, 0. This is 0, 0.4, 0.8, 1.2, 1.6, 2. This is 2. The middlemost line is 2. 2.4, 2.8, 3.2, 3.64. So continue like that. So 4, this is 4. 4.4, 4.8, 5.2, 5.6, 6. 6.4, 6.8, 7.2, 7.6, and 8. So whatever scale you choose, divide that by 10. And using that value, when you divide by 10, you get a value, right? Using that value, you should skip count to understand the value of every subdivision on your x-axis or y-axis. So now we have to mark the frequencies 12, 18, 27, 12, 18, 27, 20, 17, 6, 20, 17, and 6. It starts from 0 to 50. Okay, so this is for 0 to 50. This is for 50 to 100. Then 100 to 150. This is for 150 to 200. 200 to 250. And 250 to 300. So what is the height for the class interval 0 to 50? 12. 12 is the height. Now, how do you read? 0.5. Okay, so this is where have I marked? This one is 5. 1 second. Let me just erase it and yeah. Yeah. Draw this again. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is at 5 centimeters. This is 5. I was telling you that the maximum value is 27. So you cannot take scale 10, 20, 30. Then the rectangles will be very small. You can take 4, 8, 12. Or you can take 5, 10, 15, 20. So this is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. And so on, children. So let's just understand how to mark 12. Okay. So this is 5. So what's the value? 5 by 10? 5 by 10 is 0.5. 5 by 10 is 0.5. So after 5, how will you read? After 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 15. So which one will be 12? 10, 10.5, 11, 11.5, 12. This one is 12. This is 12. So you should draw a rectangle like this. 0 to 50. See here? 0 to 50. The height is 12. Then 50 to 100. The height should be 18. So you please, like take that on your, see that on your scale correctly. And the rectangle, supposing 18 is here. Supposing 18 is here, then your rectangle should go to that height 18. 50 to 100 is 18. 50 to 100. See here? 50 to 100. The height is 18. Okay, so this will be misguiding. So I'll take away all this. I've told you how to read the subdivision, children, so you cannot go wrong. Then 100 to 150, the height of the rectangle is 27. 100 to 150. The height of the rectangle is 27. So you should go up to that height. Find 27 on the y-axis, go up to that height. And then that is 100 to 150. 100 to, see here, 100 to 150, the height is 27. So like this, you should go on, children. The most important thing is how to read the subdivisions. I hope all of you understood that. And the second important thing is The rectangles in the histogram should not be very short, nor should they be very tall. So you must decide the scale accordingly. So here the maximum value is 27. So 5, 10, 15, 20, 25, 30 should be good. Or if you feel there are a lot of multiples of 3, you can take 3, 6, 9. 5, 10 is ideal, children. You can go with 5, 10, 15, 20, 25, 30. That's all is a histogram about. A histogram is a graphical representation of a frequency distribution. So that means, okay, frequency distribution with continuous class intervals. That means the frequency distribution must have class intervals. If the frequency distribution does not have class intervals, supposing you have a frequency distribution like this, ungrouped frequency distribution, like you have X values and F value, like number of children, no children, 5 families, 1 child, 4 families, 2 children, 10 families, 3 children, 8 families, like this. This one is not a, this one is a frequency distribution because we have frequencies. Because we have frequencies, it is a frequency distribution. But it is an ungrouped frequency distribution. It does not have class intervals. No class intervals, then you cannot represent it using a histogram. Histogram is a graphical representation of a grouped frequency distribution with continuous class intervals. Grouped frequency distribution means it should have class intervals, and the class intervals must be continuous. I can include that word grouped here. Grouped frequency distribution with continuous class intervals. There must be class intervals and frequencies. Only then histogram. Class intervals, frequencies. Then you can put a histogram. And the class intervals must be continuous. So you should, use the class intervals and the frequencies and decide the height of the rectangle. So 0 to 50 means 0 to 50. So the rectangle should be only in this range. So the height is 12. So something like this. So when you see this rectangle, you must be able to say the class interval and the frequency. When you see this rectangle, you must be able to say the class interval and the frequency. So the class interval is 0 to 50 because we have put the rectangle like that. See here, 0 to 50. And the frequency is 12. Next to 50 to 100. So supposing like this. This is class interval 50 to 100. This is class interval 50 to 100. And the height should be like 18. Okay. All these graphs I've already made, children. I don't know in which presentation I've saved it. So I didn't want to waste time. That's why I'm doing it. I'll share these images like I did for the last class also. Last class also I shared the images. I told you the presentation was old. I'll just change it and then share it, and I shared it with you. Whatever we discussed in the last class, I've already shared the images. Yeah. Next question. Yeah. Look at this one. Marks 0 to 10, 10 to 30, 30 to 45, 45 to 50. Oh, the class intervals do not have a uniform size or a uniform width. So 45 to 50, 50 to 60. Number of students. 0 to 10 is 8. 10 to 30 is 32. 30 to 45 is 18. And 45 to 50 is 10. And this is 6. Now the earlier question, the class intervals, earlier question, we had class intervals. And the class intervals had a uniform size or a uniform width. What did we have? Yeah, 0 to 50, 50 to 100, 100 to 150, and so on. So the size was 50 everywhere. 0 to 50, 50 to 100, 100 to 150, 150 to 200, and so on. So the width was the same everywhere. So there was no changes we had to do. It was very comfortable. We just put the histogram like that. We did not have to modify the frequency table because in the frequency table, we had class intervals of uniform width and we had the frequencies. That's what we want. If we have to put a histogram, we need a grouped frequency distribution with class intervals of uniform size. So in the first question we did, the class intervals were 0 to 50, 50 to 100, 100 to 150, and so on, where the size was 50 everywhere. But here you see that the size is different, 0 to 10, 10 to 30, 30 to 45, 45 to 50, 50 to 60. So now, which is the least size here, children? What is the size of the class interval 0 to 10? What is the size? What are the values this one holds? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 belongs to the next class interval. So size is 10. You count. In this class interval 0 to 10, what are the integers that can be accommodated? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 10 will go to the next one. So the class size is 10. Or 10 minus 0, 10. What's the size of the class interval 10 to 30?
20.
20. 20. 30 minus 10, 20. What is the size of the class interval 30 to 45?
15.
15. What's the size of the class interval 45 to 50?
5.
5. What's the size of the class interval 50 to 60?
10.
10. Now, which is the minimum size in this? Which is the minimum? Which is the smallest size in this?
5.
5 is the smallest size. Take that smallest size. Take the smallest size. You don't have to write all this. You can just see, and you can see your size is 10, 20, 15, 5, and 10. So 5 is the smallest size. So keep that size 5 in your mind. Keep the size 5 in your mind. Now in the rough column, or let me show you the calculation here itself for adjusted frequencies. We have to create another column called adjusted frequencies. Adjusted frequencies. So I'll tell you how to work that. Very simple. Now for the first class interval, what is the size, children? 10. 10 is the size. If 10 is the size, the frequency is 8. If 5 is the size, then what should be the frequency? If the size is 10, see here, what is the size here? 10. What's the frequency? 8. If the size is 10, then the frequency is 8. If the size should be 5, then what should be the frequency? So you can work this. There's nothing but 10 by 8 is equal to 5 by x. So when you cross multiply, 10x is equal to 40. X is equal to 4. So x is 4. So the frequency is 4. Then for the next one, what is the size? 20. What is the size? 20. If 20 is the size, the frequency is 32. If you want the size to be 5, then what should be the frequency? You can use x. See, this is your own calculation. This you're going to do in the rough column. So you can put an x, or you want to use a different variable, you can use it. Y. So 20 by 32 is equal to 5 by y. So y is equal to 20 into y is equal to 32 into 5. So y is equal to 32 into 5 by 20. When you work this, you get 8. Has anyone learned a formula kind of in school? Then I can see if formula means you don't understand why the formula is like that. So I'm just telling you, I'm explaining to tell you what is really behind the formula. How many of you have learned a formula to find the adjusted frequency? Tell me something. My God. Okay, it's fine. I'll tell you both. I'm not getting any response. So I'll tell you both. So you get 8 here. You get 8 here. I'll tell you the third one, and then I'll also tell you the formula. Now here, children, the size is 15. The size is 15. If 15 is the size, then its frequency is 18. But what is the size you want? 5. If the size should be 5, then what is the frequency? And work this. 15 is to 8 means 15 is to 18 means 15 by 18 is equal to 5 is to x means 5 by x. So work this and find the value of x. So x is equal to 5 into 18 by 15. So you get 6. Or if you have learned a formula, I'll tell you the formula. The adjusted frequency is equal to adjusted frequency is equal to the desired size, the desired class size, the desired class size by the actual class size into the frequency, desired class size by the actual class size into the frequency. The adjusted frequency is equal to you want to have a particular class size, no, that desired class size by the actual class size into the frequency. So you can use this formula also. This will make your work easier. Just put it in the formula so you can. So what is the desired class size? Because the smallest size is 5, that is your desired class size, 5. The smallest size, we checked everywhere. The smallest class size is 5. So that is the desired class size, 5. By what's the actual class size for this class interval? 10. Into the frequency, 8. When you work this, you get 5 ones are 5 twos are, so 4. Now tell me for the others, children. Use the formula and tell me for the others. What is the desired class size? The desired class size is 5. Why? What's the actual class size?
Then
So see here, what's the actual class size?
20, mom.
20. Into the frequency. What's the frequency?
32, miss.
32. Okay, so 5 ones are 5 fours are. 4 ones are 4 eights are. So frequency is 8. The adjusted frequency is 8. Now here, the desired class size is the same everywhere, 5. You want the class size to be 5. How did you decide on that class size? Whichever is the smallest. You check the class sizes everywhere. You check the class sizes everywhere. Here the size is 10. Here the size is 20. Here the size is 15. Here it is 5. Here it is 10. This is the smallest. So that is your desired class size. Actually, you can take anything. Not that you should take the smallest only. Anything can be taken as the desired class size. We normally take the smallest. You take the smallest only. You can take anything, but you take the smallest. So first you should, when should you do this? When the class intervals don't have a uniform class size. The class size is different. In every class interval, the class size is different. Then you should find this adjusted frequency column. Using the formula, desired class size 5 by the actual class size. What is the size here? 10. Into that frequency 8, like that. Now tell me for the third one, children. What is the actual class
15.
size? 15. Into the frequency?
18.
Into the frequency 18. Correct. Is equal to 5 ones are 5 threes are 3 ones are 3 6 are 18. 6. Next one. Desired class size is 5 by what's the actual class size? 5. Into the frequency 10. So you'll get the same thing. 10 only you'll get. The next one, what's the desired class size? 5. By what's the actual class size?
10.
10. Into the frequency. Yeah, into the frequency. 6. So 5, so you get 3. So nothing. You should now make the histogram using these frequencies. That's all. The method is the same. But you should use these frequencies. You must use these frequencies. That's all it is. Don't bother to write anything. I'll share everything with you. So now when you put the histogram, the scale, you must take as usual 0, 10, okay, 20, 30, 40, 50, 60. Take it as usual. Don't take only the values you see here. You take all the values. 0, 10, 20, 30, 40, 50, 60. All right. Now, what's the height? 0 to 10, what should be the height? Don't see this one. This one, height should be 4. 0 to 10, the height should be 4. So Something like this. Okay, 0 to 10, the height is 4. Here you can take values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 itself. See, because the adjusted frequencies are 4, 8, 6, 10, and 3. So small they are. So you can take 1, 2, on the y-axis. On the y-axis, you can mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, children. Okay, 10. So 0 to 10, the height is 4. 0 to 10, the height is 4. This is 0 to 10 and the height is 4. Then 10 to 30, the height is 8. See, then you don't take, all this will not come. Take only the adjusted frequency as the height. 10 to 30, the height is 8. 10 to 30, okay, the height is 8. So height 8, here it is. Ten to 30. The height is 8. Then 30 to 45, the height is 6. 30 to 45. 45 means it will come here. So mark that 45. 30 to 45, the height is 6. Where is 6 here? So 30 to 45. The height is 6. Then 45 to 50, the height is 10. 45 to 50. So this rectangle will be thinner. 45 to 50. The height is 10. And 50 to 60, the height is 3. 50 to 60, height is 3. That's it. On the x-axis, you must show all the numbers. If you start 0, 10, show 20, 30, 40, 50, and 60. You can take one extra number 70 also. We will not use it, will not need that, but you can also mark 70. Then after finding the adjusted frequencies will be the heights of the rectangles. Forget the original frequencies given. That's all. So now read. How do we read? 0 to 10. For 0 to 10, the height is 4. For 10 to 30, the height is 8. For 30 to 45, the height is 6. For 45 to 50, the height is 10. And 50 to 60, the height is 3. The rectangle will start at the lower limit and it will go, as high as the frequency, and it will land at the upper limit. See, 10 to 30 means, see, 10 is here, lower limit, and 10 to 30, upper limit is here. 10 to 30, the height is 8. So when to find adjusted frequencies? When the class intervals don't have uniform width, the uniform size, then you should find adjusted frequencies. This is the only variation you can get. In your syllabus, you will have only this variation. Either the class intervals will have the same size, like 0 to 20, 20 to 40, 40 to 60, 60 to 80, and so on. Size will be the same, and frequencies will be given. So you should take a suitable scale for the y-axis, and the frequency will be the height of the rectangle. But if the class intervals have different sizes, then you should find adjusted frequency. And to find the adjusted frequency, the formula is adjusted frequency. The formula is the desired class size. What class size you want? What is that uniform size you want? That desired class size by the actual or the original class size. Actual class size into the frequency. Into the frequency which is given for that class interval. So you can see here, we want the size to be 5. But what is the actual size? 10. Into the frequency 8. For the next one, the desired is 5. But what is the actual in the second one? 20. Into the frequency 32. Like this, you should find the adjusted frequencies, and these will be the heights of the rectangles. And depending on these numbers 4, 8, 6, 10, and 3, you should decide what scale you should take on the y-axis. So when the number, see, when the maximum value is 10, so you can take 1, 2, 3, 4 itself till 10. Am I clear, children?
Yes, ma'am.
Okay. Let me just check. Okay. Now, I think you can even get a question like this. What if the class intervals are not continuous? What if the class intervals are not continuous? So if the class intervals are, say like 10 to 14, then 15 to 19, 20 to 24, 25 to 29, and so on, children. Okay. And frequency, I'll just take some values like 300, 980, 800, some 570, and so on. Now, in this case, what you have to do is when the class intervals are not continuous, you should make them continuous. When the class intervals are not continuous, you must make them continuous because a histogram represents closely packed rectangles. Rectangles will be closely packed like this. It will be closely packed like this. There should not be space between two. It's not a bar graph to have space between the two rectangles. So it cannot be like 10 to 14. Supposing this is 10 to 14, then 15 means there'll be a gap. No, 15 to 19, something like this it will be. Then 20 to 24. So gap again, 20 to 24. Then 25 to 29. There'll be a gap again. No. Histogram, there should not be any gap between the rectangles. The rectangles will be closely packed. That means here, if the class intervals are not continuous, you must make them continuous. Now, how? Take any two class intervals. Subtract these two values. What is 15 minus 14? 1. And what is 1 by 2? 0.5. 1 by 2 is 0.5. Take any two class intervals. Take any two consecutive class intervals. You can even take this and this. Subtract 25 minus 24. Or if you take these two, you should do 20 minus 19 or 15 minus 14 like this. Okay. So take any two class intervals. Supposing you take these two, subtract these two numbers, 15 minus 40. That is, you should subtract the lower limit of the second class interval and the upper limit of the first class, the previous class interval. The lower limit of one class interval and the upper limit of the previous class interval. So 15 minus 14, 1. Find the difference and then divide by 2. Always divide by 2. So you get 0.5. Now what you should do? To all the lower limits, subtract 0.5. And to all the upper limits, add 0.5. 15 minus 1, 14. Sorry, 15 minus 14, 1. 1 by 2 is 0.5. That's how we got 0.5. So what you should do? That 0.5, subtract 0.5 from all the lower limits and add 0.5 to all the upper limits and find the new class intervals. So 10 minus 0.5, 9.5. 15 minus 0.5, 14.5. 20 minus 0.5, 19.5. 25 minus 0.5, 24.5. On the upper limits, you should add 14 plus 0.5, 14.5. 19 plus 0.5, 19.5. 24 plus 0.5, 24.5. 29 plus 0.5, 29.5. Add to all the upper limits, subtract from all the lower limits. Now you see that the class intervals have become continuous. 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5. Now they become continuous. Since it's time, children, we'll talk about the graph, making the histogram in the next class, but it's the same, that's all. You should show these values on the x-axis, 9.5, 14.5, 19.5. You must show these numbers. 9.5. I'll tell you about the kink in the next class. There's something called a kink. Okay, I'll tell you about that in the next class, but nothing much. Should just show these values, 14.5, then 19.5, then 24.5 like this, and then 9.5 to 14.5, the height is whatever, 300. So like this. Then you'll keep going like this, that's all. I'll talk about this kink in the next class. Making the histogram is the same. You must go up to this height, 300, 980, 800 and 570. Take a scale accordingly. So maybe here it should be 100. 100, 200, 300 and so on. So this is when the class intervals are not continuous. You should make them continuous. I'll just ask you one more. Make the class intervals continuous here, children. Supposing I say 4 to 8. Yeah. Now we see that the class intervals are not continuous because 4 to 8, and it doesn't continue from 8. It is 10 to 14. Then it's 16 to 20. Then 22 to 26. The class intervals are not continuous. So how do we make them continuous? What is 10 minus 8? 2. And the difference you should always divide by 2. The difference should always be divided by 2. 10 minus 8 is 2. And 2 by 2 is 1. Or you can find the difference between these two also. 16 minus 14. 2. And divide that difference by 2. Divide the difference by 2. Take any two consecutive class intervals. Subtract the lower limit of the, the second one from the upper limit of the earlier one. So 10 minus 8, 2. Divide that by 2. 1. 2 by 2, 1. Now what should you do with 1? Subtract that from all the lower limits and 1 to all the upper limits. Whatever number you get, you should subtract that from all the lower limits. So minus 1. And to this you should add 1. You must find this difference, divide by 2. 2 by 2, 1. Subtract from all the lower limits. So 4 minus 1, 3. 10 minus 1, 9. 16 minus 1, 15. 22 minus 1, 21. And upper limits, 8 plus 1, 9. 14 plus 1, 15. 20 plus 1, 21. And 26 plus 1, 27. So you can see 3 to 9, 9 to 15, 15 to 21, 21 to 27. The class intervals have become continuous. So this is how we make the class intervals continuous if they're not continuous. So when the class intervals are not continuous, you should make them continuous and then make the histogram. If the class intervals are continuous, but they have different sizes, then you should find the adjusted frequency. And then you should make the histogram as usual. All right, children, I've taken 15 minutes of your time. How many of you are here? Very nice. Online children, use the emoji, raise your hand. Abhishek, Laksha, Sadhna, Sabarna, Amritsa, Haripranav, Anugraha, Swati, Blessy, Sahana, Aniruddhan, Krishna Priyan, Niveda, and Prenu. All right. All right, children. So that's it for today's session. All that we discussed in today's class, I'll share the images. Please complete it by Friday. That's very important. Please complete it by Friday. All right. Thank you, children. Good night. You may leave the call.
Thank you, ma'am. Good night, ma'am.
Thank you. Good night.
Thank you, ma'am.
Thank you, children.